Everyone, in my last two videos, the audio was not working, so I have repaired my laptop as it was having some internal issue. So this is supposed to be our day 24. If we as I have skipped the days between, so if we consider those days, so this is our day 24. So what I am going to do, I am going to consider this as day 24, but I am going to upload videos later on the work which I am going to do on the work which I am missed on a particular day. So hello everyone, welcome to day 24 of learning DSA and development. So today in the DSA, I solved two problems. Let me first show you. Okay, the first problem was the intersection of two linked lists, and the second was to add one to a linked list. Okay, so speaking on the intersection of two linked lists, I have uploaded I have solved this question with the three approaches. So I would like to explain you the brute force. The brute force was to add all the elements from the if we consider this as the A linked list, so we will add all the elements in the hash map, and while traversing the B linked list, we will check that does that map contains this element. If contains, we will return this element, and this is the intersection of that. Then moving on to the data approach. In the data approach, what I have done, I have first took an counter, this n1, which will first count the length of the list A, which will count the length of the list that is 5. Second will count the n2 will have the count of the linked list B, then it is 6. So we took the difference. If n1 is greater, let me show you before. If, if the n1 is greater than n2, then we will find out the difference and we will loop till that difference and cover the means we will place the head over there. Pointer on that head we will consider that as head. So over here the difference is as n2 is greater, the difference is 1. So what we will do, we will skip this b1 now and point the point a pointer over here on the b2 and then simultaneously compare the points and check if they there is an intersection point. Then the optimal approach is to start so for the A linkage we will start from the A1, B linkage we will start from the B1, and we will simultaneously uh, just complete one by one step. And what will happen that when we point from the A, A means the pointer which we have placed on the will get adjusted, then it will point to the head of the B linkage. Same with the B linkage. If the pointer of the B linkage is adjusted, then it will point to this. If we do this, then the net difference, which is actually over in this case 1, it gets it becomes 0, and they will in the second iteration they will point on the same knob. So this was this was the three approaches. Then moving on to the add one to a linked list, in which I have solved it with two approaches. First the brute and then the means we can say that first the iterative and second the recursive one. So what I have done, here I have wrote the reverse function. So in the iterative one, first we need to reverse. So we reverse the linked list, then took a carry one and add it. Okay, add it, and if the element is less than 10, then we put the carry in the break. But if it's greater or equal to 10, then we put the 0 over there, everyone, we do this for the other one. But if the carry is equal to 1, then we complete and then reverse it again and point it and return it. Okay, so this was the iterative approach, but about the recursive approach. This part is same, but here we have wrote a function which will recursively call. In this case, when it becomes null, then it will return 1. Over here we are actually returning the carry. Then we will call the next node, then add a in the carry, same process, same process will be repeated over here. So that's all for day 24. Stay tuned for day 25. Thank you.